Hello friends, welcome to another video tutorial on Kafka with Python. Today we are going to discuss partition assignment strategy across multiple consumers within same consumer group. So before going ahead with today's discussion, you should have a clear idea on Kafka consumer group, which I already covered in my previous video. If you have not went through that, I will request you to go through that particular video first. The link I'll be providing in the description box, because that prerequisite concept will surely help you to understand today's topic in a detailed manner. So just a quick recap. Suppose we are having a Kafka topic and that topic is having multiple partition. Okay, in this case 3 partition, right? Here these small boxes are indicating individual messages or events, whatever our producer has published in real time with increasing offset, right? And now suppose we are having a consumer group in the right hand side. Within that consumer group we are having 2 consumer, and as we already discussed earlier, that consumer group is basically used to increase the processing speed in the consumer side. Like here you can see we launched 2 consumer within the consumer group, and if you recall our previous video, we also discussed this point that one consumer can consume message from one or more than one partition, but from one partition multiple consumer cannot consume the message. Like here in this particular picture you can see the consumer 1 is consuming the message from partition 0 and partition 1. Consumer 2 is consuming the message from partition 2. But it is not possible from partition 2 the message will be consumed by consumer 2 as well as consumer 1. Right? Maximum from one particular partition only one consumer can consume the messages. Already we discussed this. So to increase the parallel processing in the consumer side, we can launch multiple consumers within a consumer group, but the maximum number of consumer can be equal to total number of partition available in a particular topic. Okay, because in that maximum case, one single consumer will consume the message from one single partition. Like here you can see we have scope of launching one more consumer, right? So here maybe consumer 3. If we launch in the backend, the rebalancing will happen and maybe the consumer 1 will consume the message from partition 0, consumer 2 will consume the message from partition 1, and consumer 3 will consume the message from partition 2. Okay, like that. Suppose you are launching one more consumer 4 within the same consumer group, then it will be sitting ideal, because from all the partition, one consumer is consuming. It is not possible that the consumer 4 will consume the message from partition 2 or partition 1 or partition 0, because already one consumer is consuming the message from that particular partition, right? So this is just a quick recap what we already discussed in our previous video related to consumer group. You can check the description link for detailed explanation. Now today in this particular video, let us try to understand how partition get assigned within multiple consumers in a consumer group. Okay, so there are different algorithms. Number 1 approach is range partitioner. So what is that? Let us try to understand. So suppose here we are having our Kafka topic. Suppose this is the topic, and like this way generally we show offset, but suppose this is our partitions. Okay, partition 0, partition 1, partition 2, partition 3, partition 4 and partition 5. Total 6 partitions are there for this particular topic, and suppose here we are having a consumer group where we are having here consumer 1 and here we are having our consumer 2. Okay, right? Now in case of range partitioner, how the partitions will be distributed among these 2 consumers? So basically one range will be assigned. Like for example, here total number of partitions are 6, total consumers are 2. So to make uniform distribution, what we can do? We can basically assign 3 partitions to individual consumer. So in case of range partitioner, one range will be assigned to one consumer. Like for example, 0 to 2, this complete range will be assigned to consumer 1. And then 3 to 5, this partition range will be assigned to consumer 2 within the same consumer group. Like that, the partitions will be distributed. Then in that case, we will understand that in the backend, range partition assigner is working. Okay. Another algorithm is round robin partition assigner. So what is that? So suppose here we are having our Kafka topic, partition 0, partition 1, 2, 3, 4 and 5. Okay. And then here we are having our consumer 1. Here we are having our consumer 2 within same consumer group. Okay. So what will happen in this case? In round robin fashion, partitions will be distributed. So partition 0 will be consumed by consumer 1. Then partition 1 will be consumed by consumer 2. Partition 2 will be consumed by consumer 1. Partition 3 will be consumed by consumer 2. Partition 4 will be consumed by consumer 1. Partition 5 will be consumed by consumer. So just like round robin pattern, following that algorithm, the partitions will be distributed across multiple consumers within a particular consumer group. Okay, right? So I hope you understood this theoretical part. Now, without any further delay, let's see the practical implementation. Let's see round robin partition assigner and range partition assigner with Python demonstration, right? So as a first step, what we will do, we will start our Kafka cluster. So for that, I will launch Zookeeper first. I will go to PyCharm. In the terminal, I will launch Zookeeper, and then here I will launch the Kafka server also in a new terminal. And then here we will basically create a topic with 6 partitions. Like in our discussion also, we considered a topic having 6 partitions, right? 0 to 5. Same thing we will see in practical experiment also. So for this case, we are creating a topic having name hello world, and we are having 6 partitions in it. Okay. So here I will run that. So here see the topic got created. If you go to Kafka logs, here within server logs, if you see hello world 0, hello world 1, hello world 2, 3, 4, 5, like that, for different partitions, different folders got created 0 to 5, right? Now here let's see our producer code. It is a very simple producer code which we already discussed earlier, that here we are doing all the necessary imports. Then here we are creating a custom partitioner, where what is our partitioning logic? That the key part will be dividing by total number of partitions. So in our case, total number of partition is 6, right? And after that division, whatever remainder is available, based on that remainder, we will distribute our message. Suppose for example, the remainder is 2, then the message will be going to partition 2. Suppose the key is 4, then after dividing by 6, the remainder is 4 only. So in that case, the message will be going to partition 4. Like that, the data will be distributed. Okay. And here we are creating our producer pointing to the bootstrap-server, localhost 9092, because it is running in our local system only. Here we are creating a simple value serializer with string encoding, and in partitioner we are defining the custom partitioner logic. Here we are giving our topic name, just now what we created with 6 partitions, and here we are publishing some messages with 1 second sleep time in fire and forget manner, as simple as that. Okay, right? Now here let's see our consumer logic. So in consumer, what we are doing, first we are importing 2 important code. One is range partition assigner, one is round robin partition assigner. So first we will discuss the lab with range partition assigner, and then we'll switch to round robin demo. Okay, right? Then here we are doing all the necessary imports, and then whenever rebalancing happens in the backend due to one particular consumer joins the consumer group or one particular consumer leaves the consumer group, then we want to print that while rebalancing, first all the partitions will be revoked and then it will be redistributed among all the consumers, whoever is up and running, right? So for that we have written a consumer listener class, which we already discussed. Just here we are printing that these partitions got revoked and these partitions got assigned. That's all. Okay. And here we are creating our consumer. We are defining our bootstrap-server, deserialization technique, then group ID. So the consumer we are going to launch within a particular group. So here we are mentioning a group ID. Auto offset reset earliest. So as you know that it can be earliest or latest. What is its significance? Already we discussed. You can check the description link for the prerequisite videos. And auto commit we don't want to keep, we want to manually commit, so we are enabling auto commit as false. And here partition assignment strategy, here we are mentioning that it should be range partitioner, that is one range will be distributed among consumers whoever are up and running. Okay, like this case 0 to 2 will be coming to consumer 1, 3 to 5 will be going to consumer 2. That way, although based on range it is getting distributed, but at least uniformity is maintained with respect to number of partitions handled by individual consumer. Right? Now here we have defined our range partition assigner, rest part is as it is. Here we are subscribing to our this particular topic, and here we are just printing the message and committing the offset. Okay. Another consumer code I have created, same code I just copied, this Python file name I have changed main2.py, same code, as if this particular one will act as a separate consumer within the same consumer group, because if you see group ID I kept same here in both Python file. Group ID is same for consumer and the rest part also same. Okay. So first we will launch one consumer and then we will start the second consumer within the same consumer group. So for that this particular 2 codes I have created. Okay. Right. Now let's see by running this particular code. I am not starting the producer first. Let's first observe only with the consumer codes. Okay. So first here I will start our one consumer within the consumer group. Okay. So first what will happen? Rebalancing will happen. and because only one consumer is running now, so all the partitions will be assigned to this particular consumer. If you see partition 5, partition 0, then here we are having partition 2, then here we are having partition 3, then here we are having partition 1, and then here we are having partition 4. That is partition 0, 1, 2, 3, 4, 5. All partitions are assigned to this particular consumer only because only one consumer is running. Now let's start our another consumer and let's see whether the partitions get distributed based on range partition assigner technique or not. Okay. So first, if you see in our original consumer, first one, what was earlier running, first what happened, that all the partitions got revoked. If you see partition 5, 4, 3, 2, 1, 0 all got revoked, and then Kafka can see that two consumers are running. Now it will distribute certain partition in different consumers. So let's see what partition got main Python file, that is first consumer. If you see partition 0 it got, and then here partition 1 it got, and then partition 2 it got. Okay, so 0, 1, 2, this range is assigned to our consumer 1. Let's go to consumer 2. What are the partitions assigned? Let's see. If you observe here, partition 4, then partition 5, and then here partition 3. That is 3, 4, 5 are getting assigned to our second consumer, and 0, 1, 2 are assigned to our first consumer. So what is happening? This is nothing but range partitioning, right? That is, we are distributing our range of partitions within one consumer, not in round robin fashion, right? Even if you start the producer, you will observe same thing is happening. Like for example, see 0 passed, 1 passed, 2 passed. So where the 0 value will go, it will go to 0th partition. Where the 1 value will go, it will go to partition 1. 2 will go to partition 2, like that, right? If you observe the main code, here see, everything it is printing, and the value part 0, 1, 2, 6, 7, 8, all these things it is printing. But point to be noted, whatever value part it is extracting, that is coming from partition 0, 1, 2 only. That's all. See, all the messages are from 0, 1, 2. And if you observe a second consumer, all the messages will be from 3, 4, 5 partition only. If you observe here, partition 3, 4, 5. That's all. Okay. That means range partitioner we understood, right? So I will stop this. I will stop this one also. I will stop our producer also. Now we will observe the round robin distribution. That is, it will be distributed one by one. Partition 0 will be going to consumer 0. Partition 1 will be going to consumer 1. Partition 2 will be going to consumer 0. Partition 3 will be going to consumer 2. Partition 4 will be going to consumer 0. Partition 5 will be going to consumer 2. So that way 0, 2, 4 will be assigned to consumer 0, and 1, 3, 5 these all will go to consumer 2, like that. Okay, round robin manner how it works. So only thing I will change, that now in the partition assignment strategy I will mention round robin distribution. Okay, so here instead of range partitioner I will make round robin in both the Python codes for our consumer section. That's all. Now here I can close all this, and then here I can start our main code. Okay, maybe some earlier messages whatever was there, let it consume, and then here I will start my second consumer. Okay, see how the partitions got assigned. See here assigned partition it is showing partition 0, partition 4, and here partition 2. Okay, if you observe our round robin discussion, partition 0, partition 2 and partition 4 are going to one consumer, and 1, 3, 5 will go to another consumer. Let's see, if you consider our first consumer here, after latest rebalancing, what are the partitions assigned? Partition 1, then partition 3, and then partition 5. Okay, so that means partition 0 went to main 2 consumer, partition 1 came to main consumer, partition 2 went to main 2, partition 3 came to main, partition 4 went to main 2, partition 5 came to main. Like that, in round robin fashion, the partitions got distributed. Now if I start the producer, you will see only in this particular main only 1, 3, 5 this kind of partition data will be consumed. Okay, see 1, 3, 5, then again 1, then 3, then 5, like this way messages will be consumed from only this odd partition, whereas from the second consumer if you see partition 0, 2 and 4, only from these partitions the data will be consumed, nothing else, right? So this is nothing but our round robin distribution, right? So I hope you understood this. This is very important interview question also if you are appearing for big data interview, especially for Kafka related profile, that when rebalancing happens, then how different partitions get distributed along multiple consumers within the same consumer group. So obviously advanced techniques are there, but you can mention widely used these two techniques, range partition assigner and round robin assigner. I hope you understood this. All the codes I'll be providing in the description box or in the comment section so that you can parallelly practice and feel the concept along with this practical experiment, right? If you find this video helpful, then please like, share and comment. Subscribe our channel if you have not subscribed till now. And don't forget to press the bell icon to get the notification of our latest videos. Thank you for watching.